Description and types of material. First, bricks. In civil engineering, a brick is defined as a structural masonry unit, typically rectangular, manufactured from raw materials like clay, sand, lime, or cement, and hardened to achieve specific engineering properties. Unlike natural stone, bricks are engineered to standardized dimensions to facilitate modular construction. Next, concrete. Concrete is a composite material composed of chemically active binding medium, cement and water, and chemically inert aggregates sand and gravel. When mixed, the cement and water undergo a chemical reaction called hydrogen, transforming the paste into a rigid, rock-like mass that binds the aggregates together. The origins of bricks as clay, sand, and lime. In construction, brick used as load-bearing walls and foundation for small buildings. For load-bearing walls, bricks are used to construct load-bearing walls that support the weight of roofs and upper floors in buildings. For foundation for small buildings, in low-rise structures, bricks are used in foundations due to their good compressive strength and durability. For concrete origin, it has water, aggregate, rock, sand, or gravel, and cement. In constructions, concrete used as foundations and beams and columns. For foundations, concrete is widely used for building foundation because of its high compressive strength and ability to support heavy loads. For beams and columns, reinforced concrete is used for beams and columns to provide structural strength and stability to buildings. Engineering properties and characteristics. This is demonstration of the material's physical and mechanical properties.
Determination of water absorption of bricks. The water absorption percentage of bricks is calculated with the help of sensitive balance and ventilated oven. The sensitive balance should be capable of weighing within 0.1% of the mass of the specimen. The required sample of bricks is taken from the stack. The specimen is kept in a ventilated oven at a temperature of 105 to 115 degrees Celsius till it attains substantially constant mass. Take the specimen and cool it under the room temperature. Obtain its weight, that is M1. Now, immerse the completely dried specimen in the clean water at a temperature of 27 plus or minus 2 degrees Celsius for 24 hours. Remove the specimen and wipe out any trace of moisture. Obtain the weight, that is M2 of the specimen after 3 minutes from the removal from water. Then, water absorption percent by mass is calculated by the formula M2 minus M1 divided by M1 into 100. Thus, you have learned how to determine the water absorption of bricks.
This is the result of water absorption comparison for brick and concrete. The following table presents the experimental data recorded and a comparison against the affected industry standard results.
Determination of compressive strength of bricks. The compressive strength of bricks is determined by carrying out the experiment in a laboratory with the help of compression testing machine. At first, the number of specimens is taken from the stack. The specimen should not contain any uneven portion in the bed faces. Then, immerse the specimen in water for 24 hours at room temperature. After 24 hours, remove the specimens and wipe it. Then, fill the frog with the cement mortar of ratio 1:3. These bricks are stored under the damp jute bags for 3 days. After 3 days, take the specimens and wipe off any trace of moisture. Place the specimens with the plywood of 3 mm on both sides in the compression testing machine, with the mortar-filled portion facing upwards. Now, apply load axially at a uniform rate of 14 Newton per millimeters square per minute till failure occurs on bricks. Note the maximum load at which the brick fails. Thus, compression strength in Newton per millimeter square is calculated by dividing maximum load at which brick fails in Newton with average area of the bed faces in millimeters square. This test is repeated for a number of specimen and average of results is taken as compressive strength of bricks for the particular batch of bricks.
Compressive strength of a concrete is defined as the ability of the concrete to withstand specific compressive forces. Compressive strength of concrete depends on many factors such as water-cement ratio, cement strength, quality of concrete material, quality control during production of concrete, etc. Generally, the specimens shaped in cube and cylinder are used for testing the compressive strength of concrete. The standard size of a cubical specimen is 150 mm into 150 mm into 150 mm, while the cylindrical specimen is 150 mm in diameter and 300 mm in length. Generally, the fresh concrete is prepared according to the required grades and the respective mix proportion. Once the fresh concrete is prepared, the inner surface of the mold is greased to avoid sticking of concrete. The prepared fresh concrete is then filled in mold in 4 layers. After filling each layer, tamping should be done for 35 times for cube and 25 times for cylinder using a standard tamping rod. Once the mold is filled, level off the top surface with a trowel. After a day, the mold is removed and the specimens are dropped into the curing tank at a standard temperature of 27 plus or minus 2 degrees Celsius. After 7 days, the specimen is taken out of curing tank and dried for a while. Then, the specimen is placed on the compression testing machine. The cube specimen is just placed on the bearing plate, while for cylindrical specimen, it is placed vertically. The instrument is adjusted such that the plate touches the top surface of the specimen. The load is applied gradually over the specimen at the rate of 140 kg per centimeter square per minute. The load at which the specimen fails is noted. Thus, the characteristic compressive strength is calculated from the ratio of load and the area. The test is generally done with the help of 3 specimens and tested for 7 days, 14 days and 28 days.
This is results of compressive strength configurations for brick and concrete.
This is the advantages and disadvantages of using brick as a building material. First, let's review the advantages. First, they are durable and lasting for decades. Second, they offer thermal insulation that keeping the structures cool in summer and warm in winter. The third, bricks are fire resistant as they don't catch fire easily. The fourth, they are aesthetic and looking good without needing extra finishing. Lastly, they require low maintenance. The disadvantages of using bricks as a building material is: the first is they are time consuming to lay one by one. Second, they are less flexible, hard to change after build it. The fourth, they have lower strength for very tall or heavy buildings. Lastly, bricks also crack from settling. And there are also the advantages of concrete. It is very strong and can carry heavy loads. Second, it is versatile and can be poured into almost any shape. Third, concrete is durable and can last 50 or more years with proper care. The fourth, it is fire and water resistant, that making it safe and long lasting. Lastly, it allows for faster construction, especially when using precast or poured concrete, which saves time. There are also disadvantages of using concrete. It is heavy, which means the structure needs a strong foundation to support it. It also provides poor insulation and requires extra materials to control temperature within a building. Third, it can crack due to drying or changes in temperature. Lastly, it has a high carbon footprint as cement production emits a significant amount of CO2, that is, carbon dioxide.
Applications in Malaysian civil engineering projects. The RC frame with brick infill system. This is the most common applications in Malaysia. First of all, the skeleton, which is the concrete, such as columns, beams, and slabs, are cast using grade 30 or grade 40 concrete. This frame carries all the structural loads, such as people, furniture, and wind. Secondly, the infill, which is the brick. The spaces between the concrete columns are filled with brick walls. These walls act as partitions and sound barriers, but does not support the building's weight. Some of the project example, which is residential housing, terrace houses, almost exclusively built using a concrete frame and sand cement brick or clay brick walls. Secondly, high-rise condominiums, such as in Kuala Lumpur and Penang. The core structure is high-strength reinforced concrete, while internal unit partitions are often brick or lightweight concrete blocks for acoustic privacy. The third one is infrastructure, which is the bridges and drains. Concrete is the primary material for bridge decks and piers due to its high strength, while engineering bricks are often used for manholes and drainage linings due to their chemical resistance.
Sustainable practice of innovations. First, 1. Green concrete. To address the high carbon footprint of cement production, Malaysian engineers are increasingly using green concrete. This involves replacing a percentage of cement with industrial waste materials such as fly ash, a byproduct of coal power plant like the Manjung Power Station. Selenium fume enhance durability and strength, and the benefit is the reducing carbon dioxide emission and divert waste of landfill, supporting SDG 11 sustainable cities. The second point is interlock compression of block ICEB. An innovation in brick technology is the interlocking brick. The concept is these bricks are designed like Lego pieces with tongue and groove joints. And the sustainability is that they are often dry stacked, eliminating the need for mortar. They can also be made using locally sourced soil mixed with a small amount of cement, significantly reducing energy consumption compared to kiln fire brick. And the third point is industrialized building system, IBS. Malaysia is moving toward IBS, where concrete components like wall or slab are precast in a factory and assembled on site. The efficiency, the reduce waste, speed up construction, and ensure high quality control and compared to traditional bricklaying.